All right, howdy everybody. How y'all doing? You have a good lunch? I had a great lunch. That was good.
Did you?
I did, in fact. I had some pizza. Yes. There's also a third of a donut. It was really good. It was really good. It was really good.
My fault.
All right, let's go ahead and get started. Welcome. This is the Digital Speakeasy, secure and anonymous access to your website. Hopefully that's what you're looking for, because you can't leave now. Howdy. My name is Dustin Younse. I am known as @MillsYobTaf basically everywhere. It's a choice I made in 1998, and now I can't back out. You can find this and many other versions of my various presentations on GitHub. And I will be tweeting out the specific version right afterwards. I am now an engineer at Acquia. I've been there 4 months. It's been a learning experience. I used to work for a small shop based out of Austin, Texas, called Four Kitchens. Maybe you heard of them. And they are a digital agency. I worked on their support team, headed it up, which means I did a lot of pretty repetitive stuff, lots of security updates, lots of pretty boring things. But every once in a while, I got to do something pretty cool when a client wanted to really do something fun. And that's what this talk came from. So I guess the big question is, what is the digital speakeasy, other than a very clumsy metaphor? So we need to step back and talk about the internet, how you browse websites. At its core, the web is just a bunch of text files and images flying back and forth. Whether it's Ethernet, whether it's wireless, anybody with the know-how and the proximity can look at exactly what you're doing. It's just the way it is. If they were to see a website come across your connection, they would see something like this. They would see the HTML. They would know the content of the website that you're looking at. But that's not really the bad thing. They also get this. They get the metadata. You've probably heard a lot about metadata in our post-Snowden world. It's not a matter of what you're looking at. It's when you're looking at it. It's where you're looking at it from. It's what you're using to look at it. These are the important details that can really hurt you if you are, say, a freedom fighter in a oppressive regime. The internet, by its very design, is a trusting network. So each of these clusters, anybody on that cluster can see what's happening on that cluster. That's just the way it's put together. It's very trusting. In 2005. I got my very first wireless laptop. It was an iBook G4. It was gorgeous. It was my baby. And I found this tool to let me do things like this. There's an app. It no longer works, unfortunately, but it was called EtherPeg, P-E-G. And it would sniff the network you were on and pull down every single JPEG that it saw. And just drop it on the screen. That's all it did. It didn't like download them. It didn't get any kind of information. But what happens is you can kind of start to get a sense about somebody just from what they're doing. So I would sit in the back of class, open this app, and see what other people were doing. This is 2005. Most people didn't have laptops at this point. So it was surprisingly simple to know who exactly was looking at what. There was one girl in one of my classes who was an amateur model. I know this because I saw lots of her amateur bikini modeling photos that she was looking at. And she had a dog that she liked to shop for because I saw her constantly shopping for dog clothes. So very, innocent. This is nothing I was going to do anything with. I wrote a paper about it, was all I did. And when I presented the paper to my class, they're like, wait, you can do what? I was like, hi, guys. Yes, me, the guy from the back. Now, this isn't as simple anymore. 100% still possible. So we'll just take that as known. So what can you do to help secretify your browsing a little bit? The first thing you can do instead of plain text browsing is HTTPS browsing. So if you've logged onto a bank website in the last 10 years, I hope they had this turned on. A lot of browsers have gotten really good. They will actually warn you before you put in your username and password, if you have it set up right, that, hey, this isn't secure. Do you really want to put your password in there? And that's a really great thing. So this is kind of the first step. And so if somebody's snooping on your traffic, they're going to see this. Some type of cryptographically text. It's still the HTML technically, but it's been run through a cipher or two. But they still get this. You still get to know who looked at the thing, when they looked at it, where they looked at it from, and what they were using at the time. It does nothing to hide this. So that brings us to the Onion router. So this is what it used to be called. It has generational names. So Gen 0 and Gen 1 were products of the US Naval Research Lab in the mid-90s, if you can believe that. And so they had the problem, if you are a Navy ship and you're out on the water with a bunch of other Navy ships, your messages are gonna get intercepted because you're out on flat water, you're broadcasting. Enemies can pick up, they spend a lot of their time just listening to traffic that other people are broadcasting. And that's, they have encryption, they have ways around that. But the problem was they didn't want people to know where the broadcasts were coming from. So in the Navy, you've got a bunch of ships going at once. So it could be 20 different ships. They didn't want the enemy to be able to tell which message came from which ship. So they came up with onion routing. This is, I think, the earliest paper I could find on this, 1996, the earliest public paper, obviously. That's what it was all about. It was about hiding the routing of the message, not hiding the message itself. And so that brings us to Tor, the onion router, which is considered Gen 2 of this technology. The US Naval Research Lab actually gave the technology to the EFF, and they productized it, if you will, into Tor. This is what you can download and you can use. That happened in 2002. They've been working on it ever since. So Tor, how does it work? So we have the standard names, Alice and Bob. Alice wants to get some information from the server named Bob. To do that, normally you go through a bunch of computers. That's just how routing works. But in this case, if you're on the Tor network, Tor generates a non-deterministic route between these computers. So you never actually know the path that it takes, which is kind of cool. And you'll notice there are 3 computers in the middle. And that is important. That is the rule of 3. So mathematically speaking, if you have 3, sorry, animation. If you have 3 connections, you can hide completely where something originated from. So you talk to the first monkey talks to the second monkey. You and the second monkey don't know who each other are. Second monkey talks to the third monkey and the first monkey don't know who each other are. And then from the third monkey, it goes to the server. So you have passed your data from one point to the other without any of these people being able to specifically say where it came from or where it went. And that is the heart of what Tor is. This is the layers of the onion, as they call it. So why bother? I mean, it seems like a lot of effort just to go to a website. I mean, sure, if I'm going to my bank, I want that to be secure. But if I'm just, like shopping for dog clothes, who really cares? So privacy, particularly online, it's kind of an abstract concept. Why is it so important? Not all governments are that forgiving. Number one, a couple years ago, the Arab Spring. More recently, the Turkish coup. This came up, this was August of last year. So if you followed the news, there was this very chaotic, like 9-hour period where there was an attempted coup in the country of Turkey. For us, it was in the middle of the night. So we kind of like heard about it a little bit before we went to bed, and then by the next morning, it was done. But then the dictator arrested 40,000 people. So in Turkey, they've got their internet locked down. It's not quite as bad as, say, China, but there's still a lot of stuff they don't want you to be able to say or do. And for those 9 hours, people just went wild. They finally said all the things they wanted to say to all the people they wanted to say them in public on the internet. And then they got arrested. So this is why privacy is important. Not all jobs are fully ethical. So this is where the stories of Edward Snowden and Chelsea Manning come from. They were military contractors. Edward Snowden was a military contractor. Chelsea Manning, she was a soldier. And both of them were doing things that they didn't feel were right. They were seeing things done that they didn't feel were right. And it's important to know that your reading habits can have consequences. So there's the Open Societies Foundation. They are a group based in New York. They have a website, opensocietyfoundation.org. And they are owned by George Soros. You may have heard of George Soros. He's fantastically rich and incredibly on the left side of the political spectrum. He is basically the arch enemy of the Koch brothers, is who he is. Last August, the foundation was hacked, and thousands of files were released. And you're like, okay, well, that sucks, but what does that mean? I don't know if you remember, we were in the middle of a presidential election at this point. And these files, you can argue whether it was successful or not. These files were used against politicians to say that, oh, at some point in your past, you received money to speak to these people. You're a bad person. We shouldn't vote for you. So just like being associated with the OSF suddenly became a very bad thing. More recent news. This is an advertisement from the EFF. They just wanted the tech community to know. We've had 8 years of fantastic growth, 8 years of prosperity. Things have changed. It's time for us as technical people to start thinking more about what it is that we're doing on a day-to-day basis. Not that Obama was fantastically great when it comes to privacy rights, but again. So hey, Tor, this seems great. Let's talk about Tor. We know the three monkeys. We know that our information is going to get to point A to point B, and nobody's going to know where it came from or where it's going. And that's fine as long as you trust those three monkeys. But what if you don't? So we're back to this diagram. If you notice, the arrows have different colors between the different areas. The green arrows indicate that the traffic is fully encrypted. That last hop, that's red, this is probably the single biggest problem in Tor as a technology. So that last monkey is what they refer to as an exit node. So this is the computer on the network that is now taking all of that private information and blasting it onto the open web. And that's how it has to be. Like, you have to get somewhere. The problem is anybody can be an exit node. It's just an option in the software. And again, you can't know for sure, but there have been plenty of rumors about government agencies setting up exit nodes and just capturing all that traffic. Can't prove it. Definitely China does this. Probably America does this, and probably everybody, because it's not that hard to do. It's a lot of data. You're not going to be able to do a whole lot with it. But if there's a specific person that you want to put in jail and make it look legit, you can probably find something on them in this output. So that brings us to hidden services. Who here has heard of the Silk Road? Right. So the Silk Road, this was a website on what they called the dark web, the dark net, where you could do stuff. You could acquire many things that you shouldn't acquire regularly. It was run as a hidden service. So when you talk about the dark web, all you're talking about are web servers, just like Google and Facebook and everything else, that aren't available on the normal internet. You have to be connected to a Tor network in order to see them and access them. That's all it means. Like any good technology, it's a double-edged sword. Sometimes it's good, sometimes it's bad. Calling it the dark web just kind of sounds cool, I guess. But let's stop doing that. It's the Tor web. It's a hidden service. That's all it is. I'm sure you all know what a web address looks like, www.google.com. This is what a Tor hidden service address looks like. A little bit tricky. So you've got 16 characters followed by .onion. .onion is not recognized by anything other than a Tor browser. And then the rest of that is a cryptographic string. It's a hash that indicates who a specific server is on the Tor network. And this is the heart of how Tor works. This is how you get to Facebook on Tor. Facebook, turns out they have some pretty cool guys and girls that work there. And they're like, hey, we should have a Tor access. Because again, if you go back to the Arab Spring, that was a boon for social media companies. Because suddenly they weren't just a sandwich message board. They were a place where people could discuss real things that affected them on a day-to-day basis. So like, hey, we should absolutely have a secure and safe way for people to access Facebook so they can talk. Obviously, they have their own ulterior motives. I was thinking about this, like, why would Facebook want that? Then you would be anonymous. Oh, wait, you logged into Facebook. Of course, you're not anonymous. Made a lot more sense. So this is the hard part of what I'm talking about here. How do you get this? So like I said, this is a cryptographic string. You can't just ask for this. There's nobody you can hand any amount of money to get an address that looks like that. Instead, you gotta do math. You gotta do a whole lot of math. So there's a piece of software called Scallion, and it just sits there and generates stuff. So you tell it, so there's 16 characters. You tell it what you want for the first however many characters. So you say, I want the first 3 characters to be ABC, and you let it go. And it's gonna sit there and generate and generate and generate and generate and generate. And it's gonna give you like how many options it has enough time to give you. And it's gonna be ABC followed by a bunch of garbage every single time. So I was running this. I used to be a filmmaker, and I have a trusty 2008 Mac Pro, which I spent thousands and thousands of dollars on. It's got a huge video card, tons of RAM. So when I was working on this project, the client wanted a vanity domain, like that Facebook one. And I was like, okay, well, let's see how many characters we can get. So I was like, well, what they really wanted was like 9 characters out of 16 to be the specific thing they wanted. I was like, okay, let's try it. And this will tell you roughly how long it thinks it's gonna take. That was gonna take 24 days, running 24/7 to get one that might work. Because again, these are randomly generated, so somebody else might already be using that. So you need at least a couple to try out. So I was like, okay, let's back that up a bit. I think we wound up getting 5 characters that they liked. So okay, that's pretty good, 5 or 6. Okay, cool. So we've got this address. That's awesome. Drupal. I mean, the client was on Drupal. They needed people to access their site. So they decided to take that last red segment out of contention. They wanted that last segment to turn green. They wanted a Tor connection from their Drupal site into the Tor network. So you're green all the way across. How do you do that? How do you do a Drupal hidden service? So obviously the first thing I do, I go to Drupal.org. I search for a module, because there's always a module, right? And there was. It was terrible. It was just a thin wrapper. It hadn't been touched on Drupal.org in over 3 years, which in security terms may as well be BC. So I'm like, okay, well, that's not going to work for us. And then, talking to the client, my contact was a technical person, he was like, well, we don't really want to put Tor on the production server. He's like, is there any other way we can do this? I was like, I mean, I guess probably. Let's figure it out. And so why wouldn't you want to put Tor directly on your production server? Well, it's not listed here, but number one, if you're on something like managed hosting like Pantheon, you can't. Not a thing they do. But just in general, they actually hosted their own stuff, which made it a little bit easier for me. But you don't want to put it on the production server. It's going to complicate your production server. It's one more thing that can break your production server, which, let's not do that. It opens up potential attack vectors because, again, there's one more thing on your server connected to the network. So, okay, let's not do that. Something else? What can we do? So I remembered the Unix philosophy, small pieces loosely joined. If you've never read this book, you should. It's really great. David Weinberger is a very smart man. And this book, I think it's 2002, 2004. I reread it last year, and man, it really holds up. He's a very forward-thinking guy. He has a bunch of other books. Read them all. They're great. He's also a very nice man. I got to meet him once. It's one of the fun things about moving from Texas to Boston is you just run into internet luminaries all the time. That's fantastic. So what would be the Unix way? Well, instead of putting the onion into Drupal, let's just put the onion between Drupal and the people trying to get there. Seems to make sense. How do we do that? A reverse proxy setup. So this is where it gets a little bit technical. At the end of the slides, I've got a bunch of resource links that you can go to check it out. So don't worry, you don't have to take notes. You don't have to memorize this. There will be a resource section. So you've heard of the Apache web server. Maybe you've heard of Nginx, Nginx. This is a newer web server that has some pretty cool tricks up its sleeve. So it can do what's called a reverse proxy setup. In this case, the Drupal server just thinks it's a Drupal server. It's just getting web connections from the internet the same way it always has. Which means you can't blame Tor if the server white screens. You get to yell at somebody else. That's great. Drupal gets to continue collecting its logs normally, which that's really useful if you need to you need to know who's visiting your site, what are they looking at, how can we pump up some content, all that kind of stuff. You don't want to lose your logs. And the Tor server, and this is the fun part, you get to torch all your logs. You get to reroute them all to dev null. They don't even exist. It's so much fun to do. It was great. So we'll get to that. So this is roughly what it looks like to run Tor. So Tor is an application and a browser. So the application is what we installed onto a Unix server. It was Ubuntu 1604. And it's literally 3 lines. Sandbox, four lines. Sandbox, port, point it at a place, and point it at a place. That's all you have to do. It's very simple, very straightforward. And Tor will then act as a go-between. And anytime somebody asks for something, it's going to then reach out to Drupal, grab the thing, bring it back, and shove it back across Tor. This is the Nginx setup. This is a little bit more complicated. So what you're doing here is you are saying, hey, if this address, this cryptographic Tor address, somebody asks for something, do some stuff. So it's actually, the web browser talks to Nginx, it talks to Tor talks to Nginx. Nginx then reaches out to Drupal, grabs the stuff, pulls it back. So a bunch of stuff, some more stuff. So yeah, it's not like it's not easy, but it's not simple, but it's relatively easy. Once you know the magic words. So again, well, how does this work? Like, isn't the connection between Tor and Drupal still going to be open for inspection? Yes, unless. So the beautiful thing about this specific client, they were on Rackspace. So they had their own virtual servers on Rackspace, which meant that they could spin up another server to host Tor on and connect to it over a private network. This is something, again, it very much depends on your setup. I work for Acquia. We could probably do this if you paid us enough. It's not going to be cheap, let me tell you. But something like Rackspace, something like AWS, if you're managing your own AWS, DigitalOcean, all of these are great options for this. So what's happening is these two are just talking to each other as if they were on the same local network. Now, if somebody breaks into Rackspace, they can still get this traffic, but at that point you got bigger problems. So we're dealing with what we can deal with here. Let's see. And like I said, like Pantheon that's not going to happen. That's not their deal. You can ask them real nice. I asked them real nice. It's not going to happen. Love them, but they do a thing. So this here, this is the internal. So we're no longer listening for the Tor address. We're now listening for this internal address, and we are proxying it as if it was talking to the right thing. Okay, so there's a problem here in that Drupal by default uses the alias to connect to things. So /node/42. That's great, but what if in a WYSIWYG field somebody typed in the full address of the website /node/node-id? If somebody clicks on that link, it's going to knock them off the Tor connection and back onto the public connection. We don't want that. I think when you're thinking about security and privacy, it is worse to promise something and not deliver it than not to promise it at all. So if you're going to do something where you're promising people a secure and private connection, talk to other people, make sure that what you are doing is the best that you can possibly do, and don't overpromise. So I found some very sketchy people and said, hey, does this look secure? When I was done, they're like, yes. And I was like, yeah. One of them works at Pantheon.
Is this because the Drupal server is available to people outside of Tor? Like,
yep.
You want it to continue to be so?
Yep.
Okay.
Yeah, you could totally lock it down if that's what you wanted.
Right.
But in this case, it's a public server. We want it to continue to be public,
Right.
but
so
also
some people
accessible.
can come before everybody else, not
Yep.
all of it.
Yep. So then we get to do some fun stuff. So Nginx, much like Apache, has modules. You can do lots of really cool stuff. Turns out the exact 2 modules we needed required recompiling the whole thing. So that added another layer of complexity. But what we did, there's Ngx HTTP substitutions filter module. So what this guy does is it listens for a specific string. If it sees that string in the traffic, it rewrites it to whatever you tell it to. This is really fun, and I really love it. This project really turned me around on Nginx. You can do so much fun stuff with Nginx, and this is one of the things. So in this case, what's the first thing we're doing? The first thing we're doing is we're looking for the canonical URL. So again, this is a publishing website. They still have the concerns of a publisher. Just because they want people to access this on Tor doesn't mean they want to lose things like SEO. Now, I will tell you, I don't know that SEO exists on the Tor network, but when a client asks, the client gets. So in this case, the reverse proxy is going to write that canonical reference to be the wrong thing. So we have to go in transit, strip it out, and put in the right thing. So that's what we're doing there. Oh, yeah, there we go. Yes, that's what's happening. So we are looking for, in this case, we are looking for any instance of the website URL and rewriting that to the Tor URL. And so this is what's going to keep people stuck. And so it's not just, so I should go back. It's not just that maybe somebody clicks a link, but they access an image or a CSS file or a JavaScript file. Any of these things can start leaking information. And so that's why we're doing this. We're pulling the HTML, scanning it, finding and replacing every instance of that name, and putting the Tor name so they stay on the Tor network. And then this, so this actually, it's a little bit low. So down here, we're rewriting the headers that are coming off of the server so that we are not lying to browsers. It's very easy to just pass through all the headers, but we wanted to be good citizens and pass along the correct headers. So we're doing some rewriting down there as well, using a second module. So this is the ideal setup. It's all well and good. At this point, our users, they're getting to the website, everything's great. They love it, we love it. But what if somebody shows up with a warrant? So this is my personal favorite part of this. Only illegal if you get caught. That's me, circa 1998. The motto of my misspent youth. More importantly, it's only secure if they can't prove anything. So this is my new motto as of last year.
There you go.
So in our ideal setup, we have all the logging turned off. We have all of the log paths set to dev null, which is the Unix way of saying black hole. This was absolutely the most fun part of this project. You never get to do this when you're working on servers because everybody needs logs. But I got to go in, and every time I touched the server, I had a little script that I would run that would delete all the things I had just done. I felt like such a hacker. But I was getting paid to do it. It was amazing. So by default, Tor has logging turned off. You can turn it on if you need to troubleshoot stuff, because you still need to troubleshoot stuff. But then you can go and you can turn it off, and you can burn everything to the ground. Nginx is going to be producing logs, so you can burn those. You can reroute those. Drupal, because it's acting as a Drupal server, all it knows is that it's getting traffic from a specific IP address. Everybody's traffic is coming from that one IP address. So what you need to lock down is the Tor server. The Drupal server can still continue being a Drupal server. And it gives you an excellent plausible deniability. It's kind of belt and suspenders, but hey, we're trying to be secure here. And again, this is the kind of thing that is possible if and only if you control the whole hosting stack. So like I said, Acquia, they would absolutely do this for the right amount of money, but they're not going to be able to do stuff like this because they have all kinds of infrastructure that is capturing that automatically, and they're not going to modify that. Well, not for anything less than a super large amount of money. But again, so if you're on AWS, Rackspace, DigitalOcean, all these things where you can control it much more fully, you can do stuff like this. You can turn off your logs, you can redirect them. It's really awesome. So there's one problem here. It's kind of slow sometimes. And again, it's because you're having to go through these three monkeys, and monkeys aren't always the most reliable. So
is it slow from the Tor network? I'm sorry, I didn't.
Oh, sure. No, yeah. So the slowness is introduced by the fact that Tor is doing extra work to pass the data around. It's gotten way better, and so Tor is the kind of system that gets better the more people use it, because it's a peer-to-peer setup. So the more people that are on the network, the faster stuff can travel through. And Tor is constantly checking the speed of things as it's routing, so it can find the most optimal routes. But the single biggest bottleneck is that third monkey, the exit node, because those typically there's a config that you go in and say, I only want this to send out 5 megabytes per second of traffic. So it depends on what level people are allowing stuff to exit. That's really the biggest bottleneck in the whole system.
Did you see, like, with Nginx modules that you installed that did the regex? Mm-hmm. Did that introduce much of a performance problem?
Nginx is so fast, not even. Yeah, it's amazing. I tried load testing this, and it didn't work because it just kept going so fast. Like Nginx by default, it was I think a 2 gig machine. It was just so fast, it's not even funny. Because at this point, it's not even doing any processing. It's not generating the Drupal page. All it has to do is pass through traffic and rewrite some strings. And it does that so fast, it's not even funny. It's amazing. But yeah, the Tor network is what's introducing all of this latency. So the question is, what if we could cut that down to 1 monkey instead of 3? And that's something they're working on. So future improvements, single onion services. This is the name that they are giving to this idea. I last looked at this last summer, and they've already made some advancements, which is really nice. I think single onion is finally in the most recent release. I've got links to check out the discussions. But the idea here is, if you are CNN.com and you want people to access you over Tor, the basic premise of Tor is that both sides get to be secret, So that's why you need the 3 hops in between. But what if you don't care? What if you're CNN.com and people know who you are? Like, there's no need to hide your visibility, your participation in this. Because you're like, whatever, I'm CNN, I'm just letting people access my website. So it turns out you can have the same amount of security and privacy for your end user with only 1 hop. So that's pretty cool. So doing this again, I would look into this, which is really cool.
So Silk Road sticks with 3 hops, CNN goes with 1.
Yes, yes, exactly. Yeah, if you have nothing to hide, then yeah, absolutely, just a single hop. That's all it takes. Onion balance. So I didn't get to play around with this because, again, it's just really fast. So there wasn't any need. But there is a project called Onion Balance that will do load balancing for your servers on the Tor network. So this is really cool. Obviously, it takes a little bit more infrastructure. But if you had a very popular Silk Road-like website, you could use this to make it faster for people. SSL certificates. So this is kind of a point of contention in the Tor world. Because for a Tor web address, there can be only 1. These hidden sites, by their nature, have unique and secure URLs. So like I said, the reason that the URL looks so ugly is because it's a cryptographic signature. It's not meant to be human readable. It is the fingerprint of a much larger private key. That private key identifies you specifically on the Tor network. There's no need really for DNS as we know it, because that address acts as your DNS address. There can only be 1. Everybody can always find you if you're connected to the network. But it's still possible to be exposed to malicious Tor nodes. So again, it's mostly the exit nodes. And your browser might try to communicate to non-onion addresses. So we've done our best to keep that from happening, but maybe it happens. Well, somebody pointed out I gave a little bit of this talk at the Boston Drupal meetup. What about JavaScript? What if you have Google Analytics turned on your website? By default, the Tor browser that you download has no JavaScript enabled, which is really nice. It has no script, the browser extension turned on, and that actually serves to make it way faster. If you don't have to load JavaScript, it's amazing how fast the web page loads. But yeah, so at this point, that is kind of on the user to provide that privacy to themselves. But it could still be possible that somehow like a malicious transparent GIF gets placed on a page and they're able to track that back. So what can we do about that? So the final red line, we said it's unencrypted as well as being unprotected by the Tor network. How do we encrypt things on the web? We use SSL, HTTPS. How do you do that for Tor? Let's find out. Thanks, Facebook. So again, they decided they wanted a Tor entry for their website. So they built that. But then like, oh, but obviously we need SSL, we need HTTPS. But again, .onion is not a valid, recognized top-level domain. So they made it one, almost. So they went to DigiCert, and I can only imagine the sack of cash was very large. And they convinced DigiCert to go to the prevailing bodies, W3C, I'm not sure exactly who oversees the TLDs, but they went to the governing body of the internet and said, hey, can we use .onion as a TLD? And they're like, no, but you can use it temporarily. It's kind of weird. So it's in this provisional state, which is kind of weird. DigiCert, as of the last time I checked, is the only certificate provider that will give you a .onion HTTPS certificate. Costs a little bit more. Of course it does. Well, so it was the cost of an EV cert. So it was like 400 instead of 100. So, significant, but if you just need the one, it's not so bad.
But like if I'm Silk Road and I go buy this certificate, doesn't DigiCert know who I am?
Well, they do. They do. You have to take your chances.
Okay, so I'm not missing something.
Yeah. No. Yeah. It's absolutely true.
They could be CNN. And
Yeah.
You might want to be yeah.
Yeah. I mean that's the thing. Like the Silk Road, they're not going to have an SSL cert. But yeah, CNN definitely could. So yeah. So this is the news article from September 2015. Special use domain. Oh, there we go. The Internet Engineering Steering Group are the people that are in charge of TLDs. So they went to them, said, hey, pretty pleased with money on top, and it happened. So I think, I don't have numbers, but I'm gonna guess that my former client was like the number 3 person in the world to have one of these, which is pretty cool. So yeah, so DigiCert, they're the only people, but they are still actively working to standardize .onion as a TLD, which would be pretty cool. Also, the Tor group themselves are working, they've actually recently put out a proposal for something called Onion, it's a silly little acronym, but like Onion NS, which is the Onion name system. So it's like a layer on top of Tor that acts as a DNS system that would give you .tor addresses. So maybe that becomes the new TLD. We'll see what happens with that. So let's see. Extra credit. So that's all really cool. We got a website. People can get to it. But what else? See, the thing about Tor is it's just networking. That's all it is. It is like that layer of the OSI model. It's like layer 4 or 5. I forget. It's been a long time since I went to college. But you can use it for just any kind of networking. So I go every 2 years in New York City. There is a conference called HOPE, Hackers on Planet Earth. They've been doing it since 1994. They do it every 2 years in the even years. It's run by 2600 Magazine, which is kind of the preeminent American hacker news quarterly. And I got to meet some of these Tor people. They're super awesome, super nice, incredibly paranoid people. And they do things like run everything on Tor. It takes, a lot of effort, but you can run all of your email over Tor, your calendaring services over Tor. They basically have their Libra homebrewed FOSS Google Docs set up using their own software. Absolutely Stallman approved. And it's all running across Tor, which that's awesome. You can do something called onion share file sharing. This is really cool. So say you know somebody and you want to give them a file, but maybe it's the kind of file that you don't want people to know that you have, and they don't want to let people know that they're getting that file. But it's larger than you could put on a website necessarily. So there's a piece of software called Onion Share that uses the Tor network to do a point-to-point connection through the network to share very large files. Now again, it's pretty slow. If you remember LimeWire in your dorm room in 2002, it's roughly those speeds. If you're moving a big file, it's still going to take a while, but it's really cool. You can do a thing. This is one of the really cool things, a non-hidden but protected share. A true, if you will, speakeasy. So by default, you have to know the address of a Tor site. You can't guess it. There's like not really search engines for it. You have to know how to get there. But if you can get there, you can get there. Nobody's going to keep you out. So it's just kind of it's a door in the alley, but you can just open the door. But you can also set up Tor plus a secret key, which is kind of like if you've ever set up your SSH config on a computer with a private key, so you can just log directly into the server without having to type a password. It's kind of like that. So now not only do you have to know the address, but you also have to have the special key, the password, to get through the door. And this is kind of the true speakeasy. But this is, again, if you're being extra paranoid. You're not CNN. You're somebody that doesn't want just anybody walking through the door. Maybe the Silk Road should have used this. And this is kind of cool. I played around with this a little bit. So like I said, the Tor network is kind of its own DNS system by default. So if you are, say, a web developer, and you're working on something locally, and you want it to share it with somebody, but you don't want to like push it to a server and set up an address or any like ngrok, any of that stuff, you set up Tor. You just give them the Tor address, and they can get directly into your computer. It's really kind of cool. So yeah, so you're completely circumventing DNS. You're circumventing, like if you have NAT restrictions, you can do some pretty cool stuff with that. Resource links. All kinds of good stuff. So I have to give all the props to the lovely people at ProPublica. This right there. They were actually the first publishers that set this up, and their help and they put some stuff on GitHub that was very very helpful. Couldn't have done it without them. They're really fantastic people. Up above there, it's just a little bit about Tor, the Tor project, and the EFF page. Talking a little bit about the SSL stuff. In the vanity domain, how you get the Facebook www.onion address, and then I just recently updated these future links, so you can check out the latest updates in single onion services, onion NS, stuff like that. Thanks. Questions? Hi. Any questions? Yes.
Do you see a trend of legitimate businesses and community-based websites and things like that moving into this kind of structure here, or is that something that you'd recommend?
I know that they're now using Signal in the White House, so I'm guessing yes. I think just in the last couple of years, people in general have been more concerned about privacy, more concerned about security. I think Tor is still kind of the leading edge of that. It's still a little bit out there for most people, but I think depending on the audience of your group, they would absolutely be a very easy and good thing to do for them. Yep. Yes.
Did I hear correctly? Your client had analytics set up on the Tor website?
They did. You can only do so much. To their credit, so they were a very large organization. We got this to the working state, and then they had to present it to their higher ups. So we never actually got to the finish line with this, and that would have been a discussion down the road. But this was the very last thing I worked on when I was at Four Kitchens. So yeah, it's kind of weird. But yeah, I mean, you could again, it's kind of the onus is on the end user to protect themselves using the browser. But it wouldn't be with all that rewriting, it wouldn't be terribly difficult to strip out a bunch of JS links and stuff like that. Yes.
So you showed how Facebook has like a special URL for Tor, but what if it seems like it would be difficult to find out the URL, the Tor URL for every single different website you want to go on.
Yes.
So is there like a simple way to find that out? Or?
It's so it's one of those things where you kind of have to know a guy who knows a guy. You know, there are search engines and message boards that keep this kind of information around. But depending on what you're looking for, they will often change their addresses with some regularity. So yeah, it's still like that little bit of an underground feel. So it's kind of thing you gotta keep bookmarks so you know how to get back to what you're looking for.
But if you,
Is there like a URL to like some sort of like very simple like search, almost like Google search things, but like Tor?
No, but that's by design. It's not because it's technically impossible. So yeah, it's at this point, it's still, you have to do some legwork to find the resources you're looking for. But they're definitely out there. If you check out the 2600, they talk about that kind of stuff pretty regularly.
so if you're like Facebook or if you're CNN, you probably publish this, right?
Mhm.
I mean, so because you're not trying to hide your address, you just want people to be able to get to it
Yes.
from over there. Okay.
Yeah, definitely.
But I'm trying to understand how, if Facebook's Tor address is known,
Mhm.
right? One assumes that protects people in countries where Facebook is banned. I mean, but it doesn't, because their ISP sees that they typed in known Facebook Tor address.
Well, yeah. So it gets a little bit tricky. So there's two things there. There is the actual address that you're typing in.
Yeah.
And then there is what they call like fingerprinting of traffic. So if you're on the Tor network, your traffic is not going through the normal means. It is like cloaked.
Yeah.
So as far as your ISP is concerned, it's just some weird bit stream that's going through. So all of the routing, you're bypassing all of like the regular DNS system, you're bypassing all of your ISP's routers, and you're routing purely on the Tor level.
So my ISP doesn't see that string Facebook.
No.
You know?
They don't see that string,
Yeah.
but that bit stream
Mhm.
can be fingerprinted. They can't know what a connection to Facebook looks like, but they can know what a connection to the Tor network looks like. And so that's where it gets a little bit tricky. There's a Google group called Google Jigsaw is their new name. They used to be known as Google Ideas. And their whole premise is they work on anti-censorship on the web. And I have a friend who worked there for a little while, and his job was making it so that you could define the fingerprint of your traffic, independent of what kind of traffic it was. So he was working with Twitter. So he started this work during the Arab Spring. So one of the first things a lot of those countries did was they would just shut off access to Twitter. You can't go to Twitter. But then obviously you go to https://Twitter, and you're able to get through that for a little while. Then they cut that off. But then you start trying to find these different ways to access Twitter. And so then they have to start looking at like, what do these things look like? Let's say, oh, well, this, like if you're connected to a VPN, that traffic looks different at the bit level than if you're just connected over a regular network. So then they're able to say, oh, VPN, cut that off, cut this off, cut that off. And he worked out a system, he called it Dust. And it worked with Twitter's only because Twitter, it's 140 characters plus a little bit of metadata. So it's very tiny, it can fit into a single packet. And he could send a barrage of those packets shaped into different forms and almost always guarantee that at least one of them would get through. So it was, it was a one-way trip. You're not going to get information back, but you could send stuff out. So yeah. And then he was like, well, the only thing that could possibly stop this is if they cut off the internet to a country, and they would never do that.
Yeah.
And then Egypt did that. So, at the end of the day, the countries get to set the rules. Making stuff look like different stuff.
So use Tor myself. So recently read that the Congress wants to sell without our permission our browsing data.
Yeah.
So the Tor addresses that I'm typing into my Tor browser are not seen by my ISP?
At this point, no. They could figure something out, but at this point, no.
Whereas they do see the addresses that I type in.
Yes.
Isn't that kind of the whole idea? You're encrypting the whole thing, headers and all. So like the headers are where the address would show up.
Yeah. Yeah. So the whole thing is hidden. Yes.
When I go to an HTTPS link, all they can see is the host I'm going to. They can't see the entire URL. But I think that's part of the encryption.
Yeah, they don't get to see everything, but they generally see enough. So yeah, like they're obviously they're not privy to the, well, okay, so here's the other thing. How many of you are connected to the UMass internet right now? How many of you have gotten an error dialog sometime during this weekend from your calendar or something that said that it can't verify the certificate of the connection? Yeah. So the thing about HTTPS is it could be broken. I don't want to scare anybody, but if you own the pipes, there's a lot of different stuff you can do. So HTTPS, it's secure up to a point only because those certificates are verified. If somebody has a valid certificate, they can decrypt the content. And those things, you know, they're hidden, they're secret, they're whatever. But that kind of stuff, you know, can and does be checked up on. If you have ever opened up a web page without going to HTTP and seen advertisements that shouldn't be there, that's because, like Verizon, they will totally inject advertising onto a web page so they get paid. That's kind of gross. HTTPS gets around that, but they're still able to fingerprint the traffic pretty well. Anything else? Well, now that you're filled with existential dread, I hope you have a great day. Thank you for coming. Enjoy the rest of the weekend, guys.